To simplify this expression, we need to cancel common factors. So just a quick reminder, like you can't just cancel an x squared with an x squared or x's into x's. These are all separated by plus or minus signs. So we need to factor these expressions in the numerator. Let's see, we have x and an x. It's got to be a positive and a negative. A positive 4 and a negative 3 both multiplied to negative 12 yet add to positive 1. In the denominator, okay, it's got to be a positive and a negative, a positive 7 and a negative 3. That multiplies to negative 21 yet adds to a positive 4. And here we can actually cancel the common factor of x minus 3. I can replace those both with 1s, but really all that's left over is x plus 4 divided by x plus 7. You can put parentheses around it or not, but that's the final answer. All right, to factor this one apart before looking for common factors, the numerator looks okay. I think I can probably just guess what works. Got an x and an x. They're both negative. A negative 1 and a negative 5 multiply to positive 5, yet add to negative 6. For the denominator, I think directly below, I'm just going to focus on this portion where I know there's a greatest common factor of 2. That if I remove it from all terms, I get x squared minus 2x minus 15. So again, here we have a greatest common factor. This way I don't have to copy down the whole problem again. I can just focus on factoring the quadratic without the 2 in it. X and an x, gotta have a positive and a negative. A positive 5, no, a negative 5 and a positive 3 adds to a negative 2, yet multiplies to a negative 15. And at this point, I see that there's again this factor of x minus 5 that can cancel, and this means my final answer is x minus 1 over 2 times x plus 3, and it's completely okay to leave your answer just like that. For this problem, there is a greatest common factor in both the numerator and the denominator, so I'm actually going to write that in as its own step, where in the denominator I can factor out an x, and in the numerator I can factor out an x squared, but also 4. And if I do that, I have 4x squared times, okay, I got x plus 8, that's good. If I factor out an x from the denominator, I have x squared plus 9x plus 8. All right, I have to take this one further because in the denominator, I see that now that the x is gone, I can break up the remaining piece into 2 pieces. That's an x for both. Both are positive. 1 and 8 multiplies to 8, it adds to 9. And okay, I see now that I have this common factor of x plus 8, and there's an x to the first here, which completely cancels, dropping this down to a 1, which you don't have to write. So that means our final answer is 4 times x, all over x plus 1. And you could get rid of those parentheses if you want to, but I'll leave my answer just like that. All right, so for this one, the numerator has no common factors. There's no greatest common factor to remove. But this one you could still factor into 2 pieces. Same thing for the denominator. The numerator is a difference of squares, meaning you're going to have a minus and a plus. Negative and positive 2 multiply to negative 4, but they sum to 0, which is why there's no middle term. For the denominator, I have x plus 3 and x minus 2. Okay, my factors of x minus 2 cancel, and I'm left with x plus 2 divided by x plus 3. Okay, for the numerator, I see there's definitely a greatest common factor. It's just a number, but it's 5. And in the denominator, the greatest common factor is 10. This whole problem changes to 5 times x squared plus 9x. And then 5 goes into 70, a total of 12 times. In the denominator, if you factor out a 10, you get x squared plus 13x plus 42. Oops, I made a slight error. Just catching that should really be 14. If you divide 70 by 5, it's 14, not 12. All right, so fixing that, And moving forward, I think, all right, I got 5. Hopefully this thing can factor into 2 terms. In the denominator of 10, hopefully this thing can factor into 2 terms. In the numerator, it's all positive. So that would have to be 2 and 7. For the denominator, again, everything is just a positive. And it would be 6 and 7. Those cancel. The numbers you can deal with too. 5 goes into itself once, into 10 2 times. What remains is in the numerator x plus 2 divided by 5 times x plus 6, and that's the final answer. When it comes to multiplying and dividing rational expressions, this really amounts to just simplifying and canceling common factors. So it's going to look a lot like the previous questions, where I'm now going to try to factor apart the numerators and denominators of each fraction, thinking these can all break up into 2 pieces. For the very first one, the numerator, it's x and an x. It's got to be a -3 and a +1. In the denominator, everything's positive, so it's x plus x. Okay, that would have to be a 2 and a 4. In my other fraction, this is x plus 1 and x plus 2. And in the denominator, it's x minus 3 and x plus 3. There we go. Everything is simplified. Now it's the fun part where, okay, the x minus 3 is canceled. It doesn't matter that they're in different fractions. One's in a numerator, one is in a denominator. I also have this x plus 2 and this x plus 2. Now, these x plus 1s are both in the top, but that means they cannot be canceled, and there's no other common factors whatsoever. The final answer here is going to be x plus 1 times x plus 1 divided by x plus 4 times x plus 3. And I'm going to leave the answer just like that. All right, these problems can, again, involve a lot of factoring, a lot of writing of several steps. So I'm going to put in a couple of middle steps where for the top part here, the greatest common factor that could be removed is an x squared. That's common to both terms. The greatest common factor in the denominator is just 1. I mean, nothing can factor out. That's not going to be very useful. But the greatest common factor for the numerator up here is going to be 2. And then for the denominator, we have a greatest common factor of, you can take out 4 as well as x cubed. So that's my first step. Just remove those greatest common factors. So in the first fraction, we took out an x squared, which means there's an x plus 9 left over. Again, you can check by multiplying this back in. X squared times x is x cubed. X squared times 9 is 9x squared. Can't do anything with the denominator in terms of the greatest common factor. Okay, in the numerator of the second fraction, if you take out 2, you're left with x squared minus 9x plus 20. And in the denominator, if you take out 4x cubed, that's 4x cubed times x minus 4. All right. That now takes us to dealing with factoring this and factoring that. And hopefully I'll see some common factors that I can remove. So I can't do anything with the x plus 9 times x squared. But in the denominator, if we do x plus 9 and x minus 5, the product is -45 and the sum is a +4. That's good. In the numerator of the second fraction, okay, that's got to be an x minus and an x minus, and I'm going to use 4 and 5. And I can't do anything with the denominator. Okay, a lot of setup there, but let's simplify. Those cancel. The x minus 5s cancel. So do the x minus 4s. Oh, 2 goes into itself once, into the 4 2 times. And this x squared completely cancels, leaving us with just 1 of those in the denominator. Like, so much stuff is gone. In fact, what's even left? The numerators are all gone. The top is just a 1. In the denominators, there's a 2 and an x. And that's how this entire thing simplifies after you multiply it. All right, so for this one here, there's only one greatest common factor that I have to worry about, and that's down here. You can remove an x, and what's left over is an x plus 1. So here I'm asserting is the greatest common factor is x. Keeping that in mind, I can't factor x plus 1, but I think I can factor x squared plus 18x plus 80. That's x times x. And if I use 8 and 10, product is 80 and the sum is 18. In the numerator of the second fraction, we have an x and an x. Everything is positive. It's 8 and 7. The product is 56. The sum is 15. And I already talked about the denominator where you can factor out x and you're left with x times x plus 1. I'll put some parentheses up here though it's not necessary. But now the x plus 1's cancel, the x plus 8's cancel. That is all that I can do. And I'm left with x plus 7 in the numerator and x times x plus 10 in the denominator. There are no greatest common factors to worry about in question 9. Both terms, or numerator and denominator I should say, in the first fraction are perfect squares. I have a difference of 2 squares for both the top and the bottom. That means I have x plus 1 and x minus 1. The product is -1, the sum is 0. Likewise for the denominator, I have x plus 2 and x minus 2. That's being multiplied to, x minus 2 times x minus 3. The product is positive 6 and the sum is -5. For this last one, it's got to be a -1 and a -3. The product is positive 3 and the sum is -4. In terms of the factors that cancel, I have x minus 1 and x minus 1. I have x minus 2 and x minus 2, as well as these x minus 3's. All that remains is x plus 1 in the top and x plus 2 in the bottom. For the 3 division problems in this homework, essentially there's just a middle step you have to put in here, and we're going to change it to multiplication, where you leave the first fraction completely alone, but you change it to multiplication and flip the second fraction. That's it. Once you do that, going from here to here, it takes us back to our approach of the previous problems. Factor and find all the ones that cancel, all the common factors. All right, so for the numerator of the first fraction, starting there, that is x plus 2 and x plus 3. For the denominator, it's x plus 4 and x plus 5. Now again, I flipped that fraction, so it's really in the numerator x plus 1 and x plus 5. And in the denominator, it's going to be x, I want 2 things that multiply to 18 yet add to 11. Okay, that's going to be 2 and 9. It's completely factored. I can cancel all the common ones, which are x plus 2 and x plus 2. X plus 5 and x plus 5, and that is it. All that remains is x plus 3 times x plus 1 divided by x plus 4 and x plus 9, and that's my final answer. All right, I started this problem by just switching it to multiplication. So again, what I did here is it started out as division, but I just flipped the fraction that I started with here at the end. All right, so picking up here, I'm going to deal with the greatest common factors, where I have a greatest common factor of 4, and here I have a greatest common factor of 2. So clearly those are going to cancel at the very end. Oh, actually this one has a greatest common factor of 10, so I don't want to miss that as well. In the first fraction, if I take out the 2, I'm left with x squared minus 7x plus 6. I can't do a thing to the denominator. Maybe I'll just put it in parentheses. If I factor out the 10 over here, I get x plus 5. Okay, that's looking good. And then here, if I factor out 4, I have x squared minus 3x plus 2. I have exponents of 2, meaning that I can definitely factor further in the numerator of the first fraction, that is x minus 1 and x minus 6. In the denominator, again, I didn't do a thing with that. That's just x plus 5. Then I have 10 times x plus 5. But in the denominator, I have 4 times x minus 1 and x minus 2. When it comes to canceling, well, 2 can go into itself once and into 4 twice. But hang on a second. That 2 actually goes into itself once and it goes into 10 5 times. So 4 I actually got rid of from the denominator because there's a factor of 2 here that I canceled and a factor of 2 here that I canceled. That leaves me with just a 1 and a 5. But now dealing with the factors, x plus 5s, those cancel, as well as my x minus 1s. And this takes me to my final answer of there's 5 and x minus 6 in the numerator, and then we have x minus 2 in the denominator. All right, again, I started by flipping that second fraction, right? So I took this, it started with division, but I flipped the fraction, the second fraction. Okay. Okay, let's look for some greatest common factors. So for this first fraction, there's an x squared. I can't do anything to its denominator, but there is a greatest common factor of 6 goes into both 18 and 24, so I can remove that 6. Whereas in the denominator, not only can I remove 4, but I can remove an x as well. Let's rewrite all of this. Factoring out an x squared, I'm left with x minus 7. There's no greatest common factor for the denominator. In the numerator of the second fraction, if I remove a 6, I'm left with x squared plus 3x minus 4. And in its denominator, if I factor out 4x, I'm left with x plus 2. I need to factor further. That's x squared times x minus 7. I can factor this denominator. It's x plus 4 and x minus 3. In the numerator, again, I think I can factor that. That's x plus 4 and x minus 1. In the denominator, there's nothing to do. It's just 4x times x plus 2. I hope a bunch of stuff cancels. Let's see. Let's see what we have here. We got an x plus 4 and an x plus 4. That's it for the linear factors, but there are... Okay, well here there's an x to the first, which I can cancel with one of those up here. Furthermore, 4 and 6 share a factor of 2. All right, there's going to be a lot of stuff left over, but in the numerator we have 3, we have x minus 7, and x minus 1. In the denominator, we have 2, x minus 3, and x plus 2. None of those things cancel. That's simplified as far as we can go. All right, so for adding and subtracting, we need a least common denominator. That's going to be the hardest part of this problem. The rest is just a process that you follow. There are no common factors between these two fractions, meaning this is my least common denominator. All right, now I just multiply in what I want over here. Here I need an x plus 2. Here I need an x minus 1. That tells me what my next step is. That is, I leave 1 over x alone, but I multiply it by x plus 2 over x plus 2. In my second fraction, which is 2 over x plus 2, I multiply that by x minus 1 over x minus 1. This means I now have a least common denominator for these two fractions, x minus 1 times x plus 2. Right? This times this and this times this are both the same as this. It's at this point where you can just write one fraction with your least common denominator. The thing that goes here is the product of these two things, plus the thing that goes here is the product of those two things. So I'm going to put that in next. That's 1 times x plus 2 times x minus 1. And essentially we're done at this point. I'm going to leave the denominator alone, but I am going to combine like terms in the numerator. So that is, we have x plus 2. By distributing the 2, we get a 2x minus 2 all over the common denominator. And I have my final answer. My final answer is 3x, the 2's canceled, divided by x minus 1 times x plus 2. And that's it. All right, again, the least common denominator for this is going to be simple. It's just x plus 3 times x plus 5. They don't share anything in common, and that tells me exactly what my next step is. For the first fraction, I'm going to multiply in the x plus 5. I need that. And in the second fraction, I'm going to multiply in the x plus 3. I can now write all of this as one fraction with my least common denominator of x plus 3 times x plus 5. The first thing is going to be x times x plus 5. That's just the product of these two things, which I'm putting here, plus the product of these two things. Just being careful to use parentheses. Distributing the x and the 3, I get x squared plus 5x plus 3x plus 9. All over x plus 3 times x plus 5. Or finally, my final answer of x squared plus 8x plus 9, all divided by x plus 3 times x plus 5. Potentially, there could be a common factor between the numerator and the denominator, but there would not be one in common, so this is my final answer. Still no common factors, so my least common denominator is x plus 6 times x plus 1. Here we're subtracting. I don't know if that's really going to change too much, but let's see. For the first fraction, I am missing the x plus 1, so I'm going to multiply that in. Minus, in the second fraction, I am missing the x plus 6, so I multiply that in. The only thing that changes now that we have a common denominator is it's x plus 6 times x plus 1, but I'm going to subtract the product of this and this, which is 5 times x plus 1. Now it's minus x times x plus 6. We got to be careful here. This negative x, when you distribute it in, is going to make both of these things negative. The sign will change on both of them. So we have, when I distribute the 5x plus 5. When I distribute the negative x, I get negative x squared minus 6x. And this is all over x plus 6 times x plus 1. If I combine some like terms, I think the way I'll choose to write it is negative x squared. 5x and negative 6x is negative x, and I have this plus 5 left over. That's all divided by x plus 6 times x plus 1. Clearly, there can be no common factors here, and that's my final answer. All right, still no common factors between my denominators, meaning the least common denominator is x and x minus 2. So therefore, for the first fraction, 2 over x, I'm multiplying it by an x minus 2. I'm subtracting, and for the second fraction, I'm multiplying in x. I have my common denominator, x times x minus 2. And I'm subtracting the product of those numerators, which is 2 times x minus 2 times 3x times x. No need for parentheses because we don't have to distribute anything. Okay, let's see, 2x minus 4, that's minus 3x squared. Again, I'll leave the denominator alone, just x times x minus 2. I would accept that as a final answer because there are no common factors to worry about, but maybe I'll write it in a better order. Negative 3x, whoa, what? No. Negative 3x squared plus 2x minus 4. That cannot be simplified with x or x minus 2. That's my final answer. I think we finally have a common factor between our denominators. If you look at this very first denominator and factor out an x, you have an x plus 1 left over. This means your least common denominator is actually x times x plus 1. The reason is you don't have to do anything to this fraction. It's all set up. If you put an x right here with some parentheses, your two denominators are now the same. I'm only adjusting the second fraction. So I'm going to choose to write the first fraction as 1 over x times x plus 1, put it in its factored form. For the second fraction, I have x plus 1, but I'm multiplying in x because that creates a common denominator of x times x plus 1. It's an addition problem. We're summing these two fractions. I didn't do a thing to the first fraction, so I'm just going to copy down that 1. And for the second fraction, it's 2 times x. And I'm going to leave my answer just like this. All right, so again, looking for a common denominator. I'm thinking there might be a common factor here because look at this. This denominator is really x plus 4 times x minus 4. That must be my least common denominator, x plus 4 times x minus 4. And the reason is, if you multiply this thing by an x minus 4, your denominators are equal. Let's do that. The first fraction is the one you have to change. There's an x plus 4, but it's just missing that x minus 4. And the second fraction, I'm not gonna adjust it. I'm gonna choose to write it differently so I can actually see the common denominator. But when I put this into one fraction, x plus 4 times x minus 4, okay, I'm adding the two. The first is going to be x times x minus 4. The second is going to be, well, just 5. I'm not doing a thing to it. When I distribute the x, I get x squared minus 4x plus 5, all divided by x plus 4 times x minus 4. There are no common factors, and that's my final answer. All right, need a common denominator, and I'm going to guess that perhaps if I factor this, I'll see an x plus 1. And you do. This is x plus 1 times x plus 2, meaning my least common denominator is the product of those two things. I'm just missing the x plus 2 in my second fraction, so I'm going to go ahead and add that in. Technically multiply it in. That's all set, but the second fraction, it has an x plus 1, it just does not have an x plus 2. These two fractions have the same denominator, x plus 1 times x plus 2. I didn't do a thing to the first fraction, it's just 3x plus 1, but I'm adding that to 10 times x plus 2. So, if I distribute this 10, just thinking about that off to the side, it's 10x plus 20 that I'm adding to 3x plus 1. That gives me a 13x and a 21. This is 13x plus 21 all divided by x plus 1 times x plus 2. And that's my final answer. All right, this one looks like it might be a little bit complicated, but let's see what we have going on here. Because the denominator of my second fraction has some numbers in it that can be factored out. If I look at this denominator, this is really 2 times x plus 5. So now it's written as factors, which is important. Over here, you can only factor out an x cubed, and when you do, what's left over is also x plus 5. Okay, I'm seeing some things common to both of these denominators. There's a factor of 2. There isn't one here, but there at least has to be 1 if you want a least common denominator, so you have to have a 2. There's an x plus 5 in both, but you only need to write it down once, because if it works for one, it'll work for the other. Now there's an x cubed here. None of those appear over here at all, but that means you have to have an x cubed. There's the least common denominator. We're going to have to adjust both of these fractions since they each have something missing from the other. For the first one, x cubed times x plus 5, the thing that's missing is the 2. So that's a little bit different. We're actually only multiplying in a number this time. In my second fraction, we have the 2, we have the x plus 5. What we do not have is the x to the power of 3. but I do have my common denominator of 2 times x plus 5 times x cubed. I'm adding. For the first fractions, it's negative 5 times 2, that's negative 10. And x times x cubed is x to the fourth. Those can't be combined, they're not like terms, and this is my final answer. The goal for dealing with an equation is to cancel the denominators, and we're going to use a least common denominator to do that. If you multiply both sides by a least common denominator, it'll cancel every single fraction. And you can put a 3 over 1 if you'd like to, but the least common denominator for each fraction is just x. So my first step is just to multiply every single fraction by x. That is, we have x over 1 times 1 over x, plus, again, you have x over 1 times, you could put 3 over 1 if you would like to, that's up to you. And then, again, it's x over 1 times 7 over x. What I've just done is multiply the entire equation by x, meaning it gets multiplied to every single term. And the benefit of this is this x cancels with that x. Nothing cancels in the second fraction, but this one cancels with this. Every single denominator is 1, which means I don't have to write it anymore. The first thing is just 1. The second is 3 times x. And on the other side, I have 7. What's going to happen here is when we multiply both sides by a least common denominator, it's going to change it from an equation that has variables in the denominator to something that's either linear or perhaps even quadratic. So what I'm going to do is subtract 1 from both sides. 3x is equal to 6. I'm going to divide both sides by 3, and that gives me the solution. X is equal to 2. So the trick is to go from something that's a rational equation to something that we already know how to solve, like this linear equation here. So again, the hardest part of this problem really is just figuring out what the least common denominator is. And there's a fraction in every single one of these, but I need a 3, and I also need an x plus 1. If I multiply that to both sides, it's going to cancel every single denominator. And I think what we're going to be left with is a linear equation. So I'm going to multiply 3 times x plus 1 over 1 by my first fraction, which is 2 over, and I'll put in parentheses x plus 1. Again, I'm going to do that for every single term. That's 3 times x plus 1 over 1. That's being multiplied to, be a little bit careful here, but this is negative 1/3. Plus, same thing, 3 times x plus 1 over 1 times, and then we have 5 over x plus 1. I can now go through and cancel all of the common factors. X plus 1 cancels with x plus 1. This 3 gets canceled with that 3. And this x plus 1 cancels with that x plus 1. I'm going to simply write down what's left over. In the first fraction, it's 3 times 2, which is 6. In the second one, I have a negative. I have an x plus 1, and that's it. And in the last fractions, I have 3 times 5, which is 15. My equation is now linear. I'll distribute the negative. I'll combine like terms. I'll subtract 14 from both sides. I'll divide both sides by negative 1. And I have my solution that x is equal to 8. So the least common denominator here is, I have no common factors, so it's got to be x plus 6 times x minus 3. So that's what I'm multiplying to every single fraction. X plus 6 times x minus 3 over 1, that's being multiplied to 4 over, and I'll put parentheses around the x plus 6. I'm going to do that to the other side. X plus 6 times x minus 3 all over 1. That is going to be multiplied to 3 over x minus 3. Again, I'll put some parentheses around that. If I now go through and cancel all the common factors, the x plus 6's cancel here. The x minus 3's cancel here. It's my job to now just copy down what is left over. We have 4 times x minus 3, and that's going to be equal to 3 times x plus 6, a linear equation. If I distribute the 4, I get 4x minus 12 is equal to, and if I distribute the 3, I get 3x plus 18. If I subtract 3x, on the left I get x. If I add 12, on the other side I get 30, and that's my final answer. Oh, this one might be a little bit sneaky because here, this factors as x times x plus 1. There are common factors between my fractions in the denominator, but the only ones that you need to get the least common denominator are x and x plus 1. This is what I'm going to multiply to every single fraction, x times x plus 1. For the first fraction, it just stays 1 over x. I then multiply this x times x plus 1 to 3 over, and I'm going to choose to write that denominator as x times x plus 1. And on the right, x times x plus 1 all over 1 is multiplied to 5 over x plus 1, which I'll put parentheses around that. Going through and canceling all of the common factors, x cancels with x cancels with x, and the x plus 1 cancels with the x plus 1. That's completely gone. And on the right, the x plus 1s cancel. Here is all we have left over. The first fraction is x plus 1, and I do not need the parentheses around that. For my second fraction, I'm left with just 3. And on the right, I get 5 times x. So if I simplify the left side, I get x plus 4 is equal to 5x. If I subtract x from both sides, I get 4 is equal to 4x. If I divide both sides by 4, I get my answer of x is equal to 1. All right, I think this is going to work out nicely. There's going to be common factors between the denominators because x squared minus 2 is x minus 2 times x plus 2. That is precisely what you need for a least common denominator, x minus 2 times x plus 2. I'm going to multiply that to every single fraction, x minus 2 times x plus 2 all over 1. It's multiplied to 2 over parentheses x minus 2. And then add, okay, x minus 2 times x plus 2 all over 1 is being multiplied to, I'm choosing to write that as 3 over, it's really x minus 2 times x plus 2 to actually see it cancel. And on the other side, same idea, x minus 2 times x plus 2 is being multiplied to 1 over x plus 2. Now the fun part is going through and canceling all of the common factors. X minus 2's cancel. The x minus 2 and the x plus 2 cancel. And over here it's the x plus 2's that cancel. To write down everything that remains, we have 2 times x plus 2 plus 3 is equal to 1 times x minus 2, so I'll just put x minus 2. If I distribute the 2, I get 2x plus 4 plus 3 is equal to x minus 2. That is 2x plus 7 is equal to x minus 2. If I subtract x from both sides, as well as subtract 7 from both sides, I get negative 9 is the answer to this question. Again, for my least common denominator, I'm really hoping that this thing factors into x plus 1 times x minus 3. And it does. This means my least common denominator is precisely x plus 1 times x minus 3. I want to try something where if you want to write all of this work down, you can, but you should be able to get to a place where you can just ask yourself what is going to cancel from the least common denominator and simply write down what is left over. Like here. If I put x plus 1 times x minus 3 here, it's the x plus 1's that cancel, meaning the x minus 3 times 1 is left over. So what's left over is x minus 3 times 1. And we can get rid of that plus 1 in the parentheses at a later time, but here I'm multiplying x plus 1 times x minus 3. It's the x minus 3's that cancel, so the x plus 1 times 6 is left over. And then the last thing, here, if I put x plus 1 times x minus 3, everything cancels, and it's just the minus 2 that's left over. I wanted to try this out in this problem because if you think ahead about what cancels, it can save you a whole lot of writing. Anyway, the rest is just to distribute combined like terms and go from there. The 1 multiplied in just gives me x minus 3, so you didn't even have to write the parentheses or the 1. If you multiply in the 6, you get 6x plus 6, and then we have this minus 2. So that's x minus 3 is equal to 6x plus 4. If I subtract 4 from both sides, I get negative 7 on the left. If I subtract x from both sides, I get 5 on the right. If I divide both sides by 5, I get this answer of negative 7/5, but that is it for this problem.